Hi, good afternoon, everyone. So we are from George Mason College of Science. So our group is with PhD students and postdoctoral professors here. And as you may know, that we work with many different agencies like NSF, Metro, DCs, and also so basically our strength is to using machine learning and some AI algorithm to solve the problem. Either the algorithm itself, we develop new algorithm, and also we try to solve problem in the traffic condition. So we take this challenge totally new from the blank. So we want to help the Fairfax County, especially the government, so how they can improve the safety and how can they envision what kind of strategy they use, is that effective, and also how they can early response to the safety issues, especially crash. So that's our topics. So yeah, I'm very proud that in 2 days we developed a new method and thousands of lines of code to show you this with all the good people sit there. Do you guys want to have a read? Yes. Thank you. Okay. So basically, I will just quickly show some. I'll first explore. The first day we explored many different aspects of this crash data, especially, of course, with many other different data sets. But the most important thing we found is that the density is different. So different area, of course, will have a different density of the crash. And so basically, some places are more like a random, so some places are more condensed, like the dark area you will see. So about the other things, the frequency of in the different years, it will change. So this is a big challenge for us because if you explore different conditions, many experts will have different knowledge of their own. Some people will argue the weather matters, the deer matters. Some other things like school zones, I heard many different people provide many proposals. So, however, this kind of expert knowledge is not enough for our government because we have so many data. So if one of them say one of things, that's not enough. So what we want to do is to have an AI solution, so like the AlphaGo. So basically, it plays a big game with all the data. So basically, how you can use all this kind of data to just help the government to make an early response. What kind of traffic condition the crash will be next? So we developed this new AI system. It's a knowledge network. So it's kind of new. So you are maybe the first audience to hear this. So basically, we have some fact we know next day it will be what kind of seasons, and also you will know what kind of weather right now, right? And also like a week patterns, the traffic week patterns and traffic condition of the next day is something we have know that. But actually, also in the data, you will find that something related to motorcycles, bicyclists, and deers, road conditions. There's something you know that will happen, but you cannot actually predict if you don't know if the deer will show on the road. So what we do is we think we use a Poisson distribution as a signal to model this. So it's a big network that you can combine all the knowledge you know and something you don't know, but it will happen because you know the history, right? So basically, using that, you can predict what kind of things will happen in the future. Yes. So yeah, just our model is pretty large, but I just got some good news. Our model finished the initial round before I present. So actually, the best model we can do is on the 4 decimal point error of future prediction. So basically, we have 38 different models working on different areas of the Fairfax counties. So yeah, so the terrible, the most terrible one is +1, -1 crash prediction. The best one is only 4 decimal point error. So it's pretty good. And yeah, the last thing is that our model is data hunger. As many data we get, it can improve itself. Trust me. So yeah, that's what we do. And thank you.
So tell us, you just ran the model. What did you learn?
Yeah. You mean personally or just?
Can we see it? Yeah.
We have a code running that on my laptop. So, but the things I learned is that actually, so it's an early warning system first, and second for the county, I just have an idea that it can be something you guys can use it to evaluate new technologies, because if you deploy a new technology and our model can, through the data, we can see some improvement. Maybe that's also another evaluation strategy for the county government to use that. Yeah, so yeah, for my personal, it's really good experience to learn.
What about the frequency of the data that you use? Is it real, through an API and real-time streaming information? Is it very up to date?
Yes. So the prediction is, so basically it's like a more technical detail. We use every day we predict the tomorrow's situation, and we use 5 years data in the past. So basically we can incrementally predict every day's traffic condition in 38 different models. They will work together and predict for the government. So yeah.
So were you able to tell? They could say, hey, I think next week there's going to be an accident here.
Next day, actually.
So the model, was the model able to start pumping out some of that information?
Yes, yes.
So where is the next day?
Oh, sorry. Yeah, it can do so. But so the arrow I just mentioned is actually from the 2015 to 2016 data. So basically, we just assume that we fit the model with all the historical years data, but we do prediction on each day. So and also, of course, we validate it because some of the data the model will not see it. So it's just like so it's, I think it's kind of quite robust.
Let me ask you a Schrodinger question here. If we all have the data and we see the predictions, does it change the predictions in half?
Yeah.
Yeah, that's a good question. But so come back to my envision for this tool. It's not just early warning for the response like policeman but also like I think it's going to evaluate just what you're talking about. For example, today you deploy a new technology, and maybe in next months you see some improvement. Basically, maybe it's tell something. Oh, one more thing. Actually, our model will give the ranking of different those knowledge. Those knowledge we will give a ranking who will have the largest impact. So, but I'm sorry that because it's still a lot of constraint. So yeah. So maybe I hope that our team, with our professor, is willing to using this tool to help our local government.
Okay, I'm just going to say, I would encourage you also to let us know what other data you would like to help improve the model.
Yeah.
It's data hunger, everything you got. So right now we consider weather, we consider road conditions, we consider light conditions, all the data we can run. So that's why it's not so fast. So, but yeah.
As long as it's linked to place and time, right? Any data that's linked to place and time.
Yeah. Of course, you need to have a place and time data for that.
I will say this group worked really hard. I was here very late, and you guys were truly hacking through the night.
Thank you. It's we are a very strong team. So I have to thank my team members. They are all super good. Thank you.
they were a large team. They took over like a whole half of the thing. So it must be difficult to kind of get all those different ideas into one team too.